All right, so for the y-intercept for number 8, 0 goes here, so 9 take away nothing is still 9 underneath there. Now take the square root of 9, we get 3. I know some of us on our OTI were leaving the square root in the answer. We don't say square root of 3. Square root of 9 is 3, drop the radical. Okay, so 0, 3 is the y-intercepts. Okay, at home, go ahead and pause and give yourself some time to try 9 and 10. All right, this one didn't involve factoring, so should have been a little bit easier. These end up just being linear equations. So 0 in for y, that just kind of drops out of the problem. Divide by 3, 4 2/3, maybe if 4.7 nearest tenth. There was no directions on that, so somewhere around there. Okay. Here's the x-intercepts. Here's the y-intercepts. 0 for x. Don't drop this negative, right? 0 minus 2y is minus 2y. Divide by -2, we get -7 for the y-intercepts. Any questions for me on 9? Okay, here's 10. Square root, want to give you a chance to square both sides when you get in that scenario. Okay, so to get rid of that radical, we square it. And I'm going to have x minus 3, add 3 to both sides, you get 3. Okay. When you get to the y-intercepts, we get a negative under the radical, right? We can't take the square root of -3. If you punch it in your calculator, you get an error message. All right, so that's not possible in math, so we say there is none. Okay, that's kind of the conclusion there. Doesn't mean there's no solution at all. There's still an x-intercept. There's just no y-intercepts. Okay, all right, we aren't going to get all the way through the symmetry, but at least we want to introduce it here, and then we'll focus on the algebra process or verifying it tomorrow. Let's start with this definition of symmetry here. Okay, go ahead and fill this in. Graphs of equations can have symmetry with respect to one of the coordinate axes or the origin. Okay, so notice it says it can have. They don't always have symmetry. Like a couple examples of the book I see right here. This says symmetry to the y-axis, meaning if I were to cover that up, take it away, I'd see the mirror image of that, right? Same thing with 22 with the x-axis. Okay, but these aren't symmetric to the y or the x-axis. I don't see that down here. So it doesn't have to have symmetry. It could. Okay, and here's a couple more examples of the types. This is symmetric to the x-axis. This one is symmetric to the y. And the origin symmetry, the best way to see origin symmetry, if you can reflect it over both. You might want to add it in there. If you can reflect it over both. So for example, let's say I were to take this graph and reflect it over the y-axis. What would that look like? Maybe kind of something like this, right? Something like that. And then if I see a mirror image of that over the x-axis, which I do, then it's considered origin symmetry. Okay? So reflect over both axes is the best way to think of that. Does it reflect over both axes? Okay, I think I'm going to stop there and give you your assignment for today. We'll pick up there tomorrow on finding symmetry by hand. All right, just like I modeled for you, once you get to finding x and y intercepts on these equation problems on starting with 23, you should show work for that. Not for the ones up here that give you a graph. It says to verify algebraically. I'll let you skip that step. Just locate them on the graph. All right, verifying algebraically is for down here, okay? So make sure you show your work starting with problem 23. I should definitely start seeing the steps involved, okay?